Hello everyone, Reza here and welcome to my channel. In this video, we're delving into the fascinating world of Gaussian splatting. We'll explore what this technique entails, its benefits, limitations, and even delve into integrating it into Unreal Engine with some handy controls for tweaking the final outcome. Without further ado, let's get started. Let's start by understanding Gaussian splatting. Unlike traditional photogrammetry methods, Gaussian splatting is a volume rendering technique that directly renders volume data without the need for converting it into surface or line primitives. That's a big difference. There are two main types of Gaussian splatting techniques. The first one is 3D Gaussian splatting, and this method, probably the one you've seen showcased on platforms and social media, utilizes the radiance field approach to connect the sparse point clouds generated during camera calibration. It offers real-time control over the size, position, rotation, and translation of points, resulting in higher quality photorealistic outcomes. However, it comes with some limitations. It uses high VRAM usage, so definitely check your computer spec before you dive into Gaussian splatting. Also, it occupies large disk space. Some of these scenes are up to 1 gigabyte for a landscape scene. It is, at the time of the recording, incompatible with existing rendering pipelines. For example, the one that I'm about to showcase in Unreal Engine does not support Lumen. And of course, real-time results are static, but for time being. Who knows what's waiting for us around the corner? The second method, which to me is a bit scary, is 4D Gaussian splatting. And that builds upon the foundation of 3D Gaussian splatting, and this technique introduces the time component, adding another dimension to your rendering process. I gotta love that. Both methods are evolving rapidly, hinting at the dynamic future of computer graphics. Now we know what Gaussian splatting is, let's actually dive into Unreal Engine and explore ways we can bring Gaussian splatting into Unreal Engine and some handy controls that are available to us to view the result. Now, before I start with Unreal Engine, I just want to show you what plugins are available and how to install them. You have two ways of doing this. The first one is free and the second one is paid on Marketplace. This is the website by radiancefields.com. Xverse is the name of the plugin. As you can see, it's free Unreal Engine plugin, only compatible with 5.3 at the time of the recording. So you basically follow the breadcrumbs. This is the GitHub page, which allows you to download the zip file, and some instructions are in the same page available to you to be able to follow and install. But just to show you, it's very simple. Once you unzip the file, you bring in your program files, find Epic Games in the program files, Unreal Engine 5.3 engine plugin. And all you need to do is to select your zip file and drag and drop it into this folder. I've already done that. As you can see, XV for Xverse, 3D Gaussian splatting. Now, with that in mind, let's go ahead and open Unreal Engine 5.3. Here I am inside Unreal Engine 5.3. The first step we would like to make, just like any other plugins that we bring into Unreal Engine for the very first time, is to activate it. So let's go to Edit and Plugin, and in here I'm going to type in XV for Xverse, and it brings XV 3D Gaussian splatting. I'm going to enable and restart. Now we have everything loaded. You may have noticed that I have a letter X, and if I go into Windows, I also have XV3D.GS, and both buttons are doing the same thing, and they allow you to bring in a Gaussian splatting scene into Unreal Engine. What I'm going to do to make sure that things are visible, I'm just going to remove some of these guys. Sphere reflection we don't need. Sky sphere we probably don't need. And atmospheric height and fog we don't need. Now I'm going to click on this icon. There is only one button, import PLY file, and PLY is the extension for any Gaussian splatting scene. Before I import, the scene I'm about to open is created by Alex DeVoe. He graciously granted me permission to utilize his scene for this specific demo, so be sure to check out his work. I will include the link to his page and the model used for this particular demo in the description below. So I'm going to go open and select the scene. We have the information inside Unreal Engine. I can go ahead and close the plugin window. We've got the blueprint and some supporting files, position, rotation, scale, and color information to allow this blueprint to work. It's as easy as dragging and dropping into the scene. You can see the boundary of the Gaussian splatting. Any type of scene that you bring comes with excessive amount of information, things that you don't need. I'm going to go and set this one to 90 degrees, my rotation, pressing E to switch to my rotation, and I need to rotate it in Z and rotate it in Y axis. Now if I zoom in, you can see that the scene is coming through. Now, before I dive right in and show you how to take what you have to the next level, let me show you the second method of doing exactly the same thing. The second method is to use 3D Gaussian plugin created by IKEA Research Institute. Again, the way that you work with this is exactly the same thing. Let me show you how. Once you download the plugin, simply drag and drop it into your plugin folder. I guess you know what to do. Let's fire up Unreal Engine 5.3. Again, I'm going to go into Edit, Plugins, and this time I look for 3D Gaussian. I'm going to enable that, and let's restart. And now that's done. Instead of having X, I have an icon here that I can click on, or Windows, Import 3D Gaussian. They don't offer any particular options. They're just simply allowing you to open the file, and the rest happens inside Unreal Engine, and it's almost identical. If I were to just point out a minor difference, is with the paid plugin, I get slightly better consistency. So during working with the Xverse, I had moments where Unreal Engine crashed. It never happened with the paid plugin. That's the only difference. Now, with that out of the way, let's go to the next chapter, pick one of these plugins and see what we can do with the PLY Gaussian splatting scene files. Now, before we talk about how incredible Gaussian splatting is and how it looks inside Unreal Engine, let's talk about limitations. The first one is if I go into the content drawer and look at the blueprint class, you're unable to access the internal structure of that. Even if you go ahead and double click on it, it's only going to clone the properties that you already see inside the details panel. So it's not going to give you anything extra. All you have through Niagara system is the user parameters. And we did talk about user parameters in our previous videos, where you can extract a property from an internal structure and showcase it in the main user interface. And anything you see in user parameters is all we have to tweak the content. So that's the first one. As for real limitations would be the plugin renders 3D Gaussian splatting data using Niagara particles. So because there is a limit to the number of particles in Niagara system, sometimes any plugins that you use import the data into multiple blocks, and those blocks sometimes create seams between the blocks. So that's why sometimes you look at the data that you bring in and you see something like cards. If I go into wireframe, you probably see how they look. So sometimes you see these seams, and each card contains the data, and the system is blending them together. So that's one limitation is, well, you see seams and artifacts. The other one is lighting support is experimental. While there is a way to somehow relight the scene, it's not going to work quite as you expect. Anything with translucency and subsurface scattering are going to pretty much fail because the light cannot go through and scatter. These are points, they're not primitives. Remember, that's the main difference between this and a geometry. And of course, lumen is not supported, shadow is not supported, ray traced translucency is not supported. Now, you may say, all right, can you, Reza, say what we can do in the engine? Well, there are things that you can actually do to present your work and showcase it. The first one, which in my opinion is one of the most important ones, would be point cloud image size. Now, point cloud image size shows how big those points are, and based on the size, they are going to blend with each other, and as a result of that, you get a better result. I am going to centralize this point cloud inside my bounding box, and this bounding box is very important. Why? Because we can crop excessive content using this bounding box. As a matter of fact, I'm going to scale up my data 5 times, maybe 10 times. Yeah, 10 should be good, so I can see things better. Sometimes you bring, let's say, a city into your scene and it's very small. And because of that, you will struggle orbiting around the scene. So make sure that it's big enough so you can actually get into the point clouds and tweak. With regard to this point cloud size, if you go too low, it creates pocket holes because those points are not close enough to cover the surface. And if you go too high, it somehow softens the result. So if I go, let's say 800, that's way too much, not to mention the blending of the points are going to create also artifact. If you go crazy high, you cannot see anything because there's a limit to what Niagara can show based on your computer spec. So if I go, let's say 2000, chances are I'm not going to get anything. I think for this particular scene, 600 would be a sweet spot. And if I zoom in, you can really see how incredible the main object is. And it's just mind-blowing to think about the fact that it's not a geometry. So you may say, that's all good. How can we get rid of this excessive amount of information around the main model? Well, you can actually crop. So if I search for crop, it says in the control type what you would like to crop, and in the crop box scale it says how much based on the bounding box you would like to remove. So if you change this without changing the control type, obviously you're not going to see anything. So I'm just going to switch from kill nothing to kill outside this bounding box. And immediately you see that I'm getting a really good result. I can bring my point cloud ever so slightly forward, and I can start removing some of these. Let's say 400, 300, I'm really pushing it, 200 should do the trick. If you get some artifacts at the front, you can actually move this back and forth. You can see I'm removing some of the data here. So I'm getting too close and a few inches back so I don't get all of those sort of hazy looking cards in front of the model. You can do the same thing for the sides. What is the default? 400. Let's try 350. Maybe 300, and you get the gist. You basically take it from there. It's just about trial and error to see which one works for you and which one doesn't. For the height, you pretty much do the same thing. The default is 285. Let's try 200, and that should do it. Something along those lines. And you can of course go to game mode. You can change your field of view to get less distortion and take it from there. You can see in no time at all, you get something presentable and the result looks spectacular. It doesn't end there. You can go into visual effects and bring post-process volume into the mix. You can go, I'm going to clear my filter and play around with exposure. So if I go infinite to go infinite bounds, so post-process volume effects will have an impact on the entire scene. Now I can go to exposure, enable exposure. Let's bring it down to 0.8, maybe 0.65 to just intensify the black areas, get a slightly better result. And of course you can have access to not only that, but also your color grading. You can see I have color grading where you can play around with temperature, lower the temperature, let's say 4500. And of course, from this point onward, you can play around with saturation. I'm going to double click on that. You can increase or decrease the saturation to just fine tune that sweet spot and play around with it. And you can add chromatic aberration, you can bring in vignette, you can intensify your shadows, so on and so forth. You can also relight the scene. So if I go in here and type in relight in my point cloud data, you can see with relighting is one of the user parameters that I can enable, and immediately I get a far better result. I can now go to exposure and maybe crank up the exposure ever so slightly. Maybe 1.3 will work just fine. And you can see how gradually but surely you are actually getting closer and closer to the ideal look. You can go ahead and relight your scene. You can go to light, bring in a point light, or even better, let me bring in a spotlight. I'm getting out of the game mode just to make sure that I'm actually covering the character in there. And let's go ahead and intensify that to a crazy number. Let's say 3000. I'm going to go with blue, and you can see somehow I'm kind of getting the result that I want. It's impacting the image. Having said that, as I said, with one of the limitations, it's not really changing the direction of the shadows. So that can be a deal breaker, and I understand why, but at least for now, it's really not supporting the way that you change shadows within the application. So some of these small tweaks you can do to ever so slightly get the result that you want, but that would be pretty much the extent of what you can do. That should do it for an introduction to Gaussian splatting, what this technique is, what you can do with it in Unreal Engine at the present time. And all I can say is the future of computer graphics is a big question mark to me. With the pace and the rapid growth I'm witnessing, the future is very, very exciting. The big question we should ask ourselves is Gaussian splatting gets fully implemented in a production environment. And if that's the case, then we need to rethink the way that we look at the traditional studio pipeline and the way that we produce work. So it's a huge change that is coming our way, and this is to me just a starting point. Well, there's one way to find out, and that is to wait, probably not for too long, to see how this technology is going to evolve. I hope you found this video useful. As usual, follow me on X, Reddit, and Instagram. Have a great rest of your day, and see you guys later.